Hidden Figures by Margaret Lee Shelterly. Dorothy Vingon, Maury Jackson, Katherine Johnson, and Christine Darden were good at math, really good. In 1943, the United States was at war. World War II, Dorothy Vingon wanted to serve her country by working for the National Advisory Committee of Aeronautics, the government agency that designed airplanes. Having the best airplanes would help America win the war. Making airplanes fly faster and higher and safer meant doing lots of tests at the agency's Langley Laboratory in Hampton, Virginia. Tests meant numbers. Numbers meant math. Math meant computers. Today we think of computers as machines, but in 1940s, computers were actually people like Dorothy, Mary, Catherine, and Christine. Their job was to do math. Because Dorothy was black and a woman, some people thought it would be impossible for her to get a job as a computer. She lived in Virginia, in a southern state where laws segregated or kept apart black people and white people. They could not eat in the same restaurant. They could not drink from the same water fountains. They could not use the same restrooms. They could not attend the same schools. They could not play on the same sports team. They could not sit near each other in movie theaters. They could not marry someone of a different race. But Dorothy didn't think it was impossible. She was good at math, really good. She knew she was the right person for the job. She applied in the laboratory, offered her a position as a computer. At work, blacks and whites were kept apart. The white computers worked in one building, and Dorothy and the other black computers worked in a different building in their separate offices. Even though they worked on the same kinds of assignments, the black and white computers used separate bathrooms and ate in separate lunchrooms. Mary wanted to become an engineer, but officials said it was impossible. Most of the engineers at the laboratory were men, and to become an engineer, Mary needed to take high-level math classes, but she wasn't allowed to go inside the white school where the classes were taught. But Mary was good at math, really good, and she refused to give up. She got permission to enter the school building and take the math classes, and she earned good grades because she didn't give up. Mary Jackson became the first African-American female engineer at the laboratory. Katherine Johnson was good at math and always asked lots of questions. In 1953, she applied to the laboratory for a computer job and was placed on a team that tested actual planes. They were flying in the air. Their research was used to figure out ways to prevent future plane crashes. In one of her first projects, she learned how to analyze turbulence for dangerous gusts of air. No one knows how many lives her work may have helped save. Catherine wanted to help the group prepare for its research reports. So she asked if she could go to meetings with the other experts on her team. Her boss told her it was impossible. Women aren't allowed to attend meetings, he said, but Catherine knew she was as good at math as anyone else, maybe better. So she asked him again and again and again. Catherine asked her boss so many times that he finally invited her to the meeting. Catherine was good at math, really good, and she thought to be treated the same as the men. She became the first woman in her group to sign her name in one of the group's reports. In the 1950s, the Langley Laboratory bought a machine computer that could do math faster than the human computers. At first, these machines made mistakes. Dorothy learned how to program the machines so that they got the right answers. She taught the woman in her group how to program the computers too. In 1957, Russia launched a satellite known as Sputnik into orbit around the Earth. The United States started building satellites to explore space too. For years, the laboratory has used math to design airplanes. Now it would need math to create spaceships as well. The government decided to change the agency's name from the National Advisory Committee for Aeronautics to the National Aeronautics and Space Administration, also known as NASA. In 1961, President John F. Kennedy told Congress, "I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to Earth." A man on the moon? But the first step to getting a man on the moon was to send an astronaut around the Earth. NASA was going to need to hire more space experts and more people who were good at math, really good. The people at the laboratory had to work together from morning to night to figure out how to send astronaut John Glenn into space and bring him back home to Earth safely. Katherine Johnson knew she could use math to help. "Tell me where you want his spaceship to land and I'll tell you where to launch it," Katherine told her boss. Katherine helped calculate the trajectories or pathways that rockets traveled through space. She had to plan Glenn's exact route from takeoff in Florida to splashdown in the Atlantic Ocean. There was no room for error. No one was better than Katherine at solving tricky math problems days before his mission. John Glenn wanted Katherine to double-check the machine computer's trajectory calculations to make sure it hadn't made any mistakes. When Katherine said the numbers were correct, Glenn was ready to go on February 20, 1962. Glenn blasted off into space, circled the Earth, made his way back home safely. Meanwhile, laws began to change so that black and white students could go to school together. Blacks fought for rights to sit beside whites on buses and to drink from the same water fountains at the laboratory. Black and white computers started working together in the same offices, eating at the same lunch tables, and using the same bathrooms. Black and white moviegoers could sit next to each other in the same theater across the country. People started to think about ways to bring equality to all Americans. Christine Darden was good at math and she loved electronic computers. She started working at Langley in 1967. Christine wanted to become an engineer, and thanks to Dorothy, Mary, and Katherine, she knew it was possible. Eventually, she became an engineer for supersonic airplanes, planes flying faster than the speed of sound. But her first job was to help with NASA's mission to the moon. The people at the laboratory prepared for years to send astronauts to the moon, about 238,900 miles away from Earth. Finally, on July 20th, 1969, the world watched as the three men arrived at the moon in their Apollo 11 spacecraft. "That's one small step for man, one giant leap for mankind," said the astronaut Neil Armstrong when he stepped onto the dusty surface. It was also a giant leap for Dorothy, Mary, Katherine, Christine, and all the computers and engineers who worked at the laboratory over the years. The moon landing was a success from takeoff to splashdown, but there was no time to rest. Once NASA landed astronauts on the moon, the people at the laboratory began dreaming of sending humans to other planets such as Mars, Jupiter, or Saturn. They started to imagine hyper-fast space planes that could travel around the Earth 7 times the speed of sound. The next adventure wouldn't be so easy and would require lots of tests and lots more numbers. But Dorothy, Mary, Catherine, and Christine knew one thing. With hard work, perseverance, and a love of math, anything was possible. The timeline.
Great job.
Oh, I thought I was also supposed